Grade 12 pre-cal, 7.5, trigonometric identities. Sum and difference identities. So these are on your formula sheet again, and you'll actually see as they're right here. These are the 6 of them we're going to use. So let's start by changing this out and see. Sometimes in calculus, when you get into it, you'll have to replace expressions like this one. So alpha and beta, sine of it. So what's in it with an equivalent expression? So what I want to do is I want to test this out first. So sine alpha plus beta, is it equal to sine alpha plus sine beta? So let's just test it out. So alpha is pi over 3, beta is pi over 4, right? And you can just find those on your unit circle. You can find all the appropriate things. So the first one, sine of alpha plus beta. So pi over 3 plus pi over 4. To add those together, we need common denominators. So 4 pi over 12 plus 3 pi over 12. Yeah, we add those. Sine of 7 pi over 12. Use your calculator. It's approximate with 0.9659. Let's see if it's equivalent to sine alpha plus sine beta. So sine alpha plus sine beta. So that's root of 3 over 2 plus root of 2 over 2, which is approximately 1.573. So are they equivalent? No. So what does that tell us about these two things? No, they're not equivalent. So what we do, we use the following trigonometric identities for sum and differences. So we have sine, these are addition ones, sine, cosine, and tangent. And we have sine, cosine, and tangent again for subtraction. So what this allows us to do, it allows us to find exact values of things like, hey, sine of pi over 12. Is pi over 12 on the unit circle? No, we don't have it on there. We don't know what it is. But what we can do is we can think of 2 unit circle angles with a difference of them. And you could do this with addition also. You experiment with it a bit. So what about this one? 7 pi over 12 minus 6 pi over 12. Yeah, that gets us our pi over 12. But 7 pi over 12, is it on the unit circle? No, that doesn't help us. 6 pi over 12, that reduces down to pi over 2. Hey, that one was on the unit circle. That's good. So let's try another set. So let's try 4 pi over 12 minus 3 pi over 12. Yep, that gets us our pi over 12. Excellent. 4 pi over 12 reduces down to pi over 3. Is that on the unit circle? Yes. 3 pi over 12, that reduces down to pi over 4. Is that on the unit circle? Yes. Perfect. So we can use these two alphas, this alpha and this beta, to get our pi over 12 so we can actually do the work. Okay? So since pi over 3 minus pi over 4, since both are known on the unit circle, we can do it. So sine of pi over 12 equals, there it is, sine pi over 3 minus pi over 4. And then you use the formula. Grab the formula, and we plug in sine pi over 3 cosine pi over 4 minus cosine pi over 3 sine pi over 4. And it's just a matter of getting the formula, plugging it in. Now what we can do is we can replace everything. So we replace them. So we have pi over 3 times, root of 3 over 2 times root of 2 over 2. We can replace those. Minus 1/2 times root of 2 over 2. Multiply, so we end up with root of 6 over 4. Multiply, we end up with root of 2 over 4. Again, they have common denominators, so we can just put root of 6 minus root of 2 over 4. That's an exact value, right? No decimals, no fractions. It doesn't go on forever. We can reproduce this over and over again. So sum and difference identities allow you to find exact values for things like, we said here, sine of pi over 12. Okay? Flip to example number 2, next page. So this one, they tell us what sine alpha is, and they tell us what cosine beta is. And what we want to do is we want to find the exact value of sine of alpha minus beta, which is really nice. But the problem is we don't have enough information. We have the sine of alpha. We need the cosine of alpha to help us. We have the cosine of beta. We need the sine of beta to help us. Okay, so let's figure this out. So let's start by drawing an angle. I find if you draw a picture of stuff, it often helps you organize your thoughts a little better here. So let's do the first one. So sine of 5 over 13. So sine of 5 over 13. Where is sine positive? Yeah, it's up here. So it's either in 2 or 1, but it tells us right here it doesn't terminate in quadrant 1, so it has to be in 2. So we draw our little thing here. So 5 over 13. So 5, right? Sine is opposite over hypotenuse, or y over r. So we can draw this out. What do we know about x right away? Well, x has to be negative if it's in quadrant 2. So how do we find that? Well, you can do Pythagorean Theorem, or you realize this is just what's called a Pythagorean triple, right? 5, 12, 13. The most common one we know is 3, 4, 5. So we do the math here. We find this is 12, so it's going to be negative 12. Okay, so we know sine alpha is 5 over 13. Can we figure out the cosine now? Yeah, adjacent over hypotenuse, or x over r. So negative 12 over 13. So good. We have all the ones we need for alpha. Let's do the same thing for beta. Now beta is cosine is 3 over 5. So cosine's positive. So where's cosine positive? Quadrant 1 and 4. But it tells us it's not in quadrant 1. So we do it down in 4. So we draw our little triangle. Cosine is x over r, or adjacent over hypotenuse. And we're looking for y. What do we know about y right away? Well, it's in quadrant 4, so y has to be negative. Can we do the math? Yeah, you can use Pythagorean Theorem and do the math, or you realize this is a 3, 4, 5 triangle, right? So then you know right away. Okay, so we got cosine beta is 3 over 5. Sine beta is negative 4. Remember, negative because it's in quadrant 4 over 5. So now we have all our betas. So we have our alphas and our betas. Now can we finally do the question? Oh my goodness. It takes forever to get there sometimes. You have to do all this pre-work to get to the actual question. So now we can find sine of alpha minus beta. So there it is. Grab the formula off the formula sheet. Plug in the numbers. Where do we get sine alpha from? Well, just look back here. You got it right there. 5 over 13. Right, just fill in all the numbers. So 5 over 13, 3 over 5 minus negative 12 over 13, negative 4 over 5. Well, what do you do first? Do your multiplication. You know that. Bed mass is always in play no matter what we do. So we multiply. We get 15 over 65 minus 48 over 65. Hey, common denominators, just subtract. Okay. So here's some steps that you can follow. Draw the triangles for alpha and beta in the correct quadrants. Make sure you get that right. Label the triangles with the given values and solve for the unknown sides. Determine which formula you need, right? Remember, there's 6 of them there, right? 3 subtraction, 3 addition. Pick the right formula and then figure out, do the work and base your answer on that. Okay, last example, example number 3. Oh, sorry, 2 examples, example 3 and 4. I should probably learn to read. Okay, express sine theta plus pi over 6 as a function of theta only. Okay, so we have theta plus pi over 6. So we're going to use sine of alpha plus beta. So there it is right there. I just wrote it at the top. So let's plug in what we know. So sine theta plus pi over 6. We write it out, right? Sine alpha times cosine beta. Yeah? Plus cosine alpha plus sine beta. And just plug in what we know. Well, we don't know sine theta, but we can figure out the cosine of pi over 6. You just use the unit circle. We don't know cosine theta, but we can figure out the sine of pi over 6. We just use the circle and we get a half. Okay? Then what do we do here? Okay, then we just multiply. So sine theta root of 3. So root of 3 sine theta. I just rearranged the order. Cosine theta times 1, so just cosine. Both have a common denominator of 2. You can just add them together. So we end up with root of 3 sine theta plus cosine theta over 2. Huh. That's all we did there. That's all it said to do it, right? It's expressed as a function of theta only. Not that difficult. All right. Example 4. Prove the identity cos t minus pi over 2 equals sine t. So what are we going to use? Well, cosine, if you notice, it's a subtract, so we're going to use cosine alpha minus beta. So there's the formula right there we're going to use. Yeah, that's the one. We just got that from our formula sheet. Left side equals right side because we're doing a proof, right? So we got this. We got sine t. All right, let's go see what we got here. So all you do is change the subtraction into this formula. So cosine t, cosine pi over 2, plus sine t over sine pi over 2. Okay, well, we can do some of this work. Cosine t, we don't know what it is, but cosine pi over 2 is really quite easy. It's 0. Sine t, we don't know what it is, but sine pi over t is 1. Oh, okay. Well, look at this here. Cosine t times 0. What's anything times 0? 0. Okay. Sine t times 1. What's that? Sine t. Oh, so we proved left side, sine t, right there, is equal to the right-hand side, sine t. So it's just a matter of doing this step. So get yourself organized. Figure out which formula you're going to use and start working through it left side and right side. It doesn't matter which side you pick. Okay?